I am Dr. Mahendran, working as a professor in the Department of Information Technology at Topological College of Engineering Technology. Today, let me explain the topic of topological sorting in graph. The topological sorting is available data structure. It is one of the non-linear data structure. Actually, the main focus of what is the meaning of topological sorting is we have to arrange the jobs in the specific order. That is the main focus of topological sorting. So as you know that the sorting is a way of organizing elements in the specific order. It may be either ascending or descending order. The similar way, we have to arrange all the jobs in the specific order. That is the logic of topological sorting. So before to go inside that topological sorting, first of all, we should know what is the meaning of the graph. The graphs are data structures used to represent connections between the pairs of elements. Here, the elements are called the nodes. It may be called the vertices also. So you just look at this picture. In this diagram, we have the 4 nodes are there. There's node 0, 1, 2, and 5. So these are called the nodes. So they represent actually the real life objects. It may be the persons or any kind of entities. There. The connections between the nodes are called edges. See, if you look at this picture, these 4 nodes are attached or associated with the help of the lines. So these lines are called the edges. So the graph is simply called the combination of the various number of nodes and edges. So the combination of nodes and edges are called graph, because the graph is the key element for learning the topological sort. Next. So this is the example of graph where we are using in our real-time environment. So if you look at this picture, here we have the 4 different types of nodes available. So the node 0, which represent some factory, the node 1, which is looking like the warehouse where the factory products are stored, that is called warehouse. Probably the node 2, which represent that shops where they sell the products to the customers. The node 3 may be that house from where we are purchasing the product from the shops. So we have the strong association between all these 4 nodes. The line which are called the edges, through the line we can connect all the nodes. So this is one of the simple example for representing graph. So in this example, we interlink the various nodes which are represent the various kind of facilities which are used for send and receive the various kind of products through the edges. So the edges which are represent the roads, probably we have assumed that we have that factory at one place, one city, that may be the Trichy, and we have the warehouse at Namakkal, that is a one, and we have the shops at Chennai. Probably the house may be in some part of Chennai. So the thing is, we are attached, we are associate all these kind of nodes through the road, right? So this is one of the simple example of graph where we are using in our real-time example. So the graph is one of the nonlinear data structure that consists of the combination of nodes and the edges, as we already explained. So this is a proper definition of what is called the graph. The nodes are sometimes referred to as vertices, and the edges or lines or arcs which interconnect the various nodes or 2 nodes in the graph are called the edges. So in the general format, the graph is represented in the terms of capital G. That is, we represent capital G equal to B comma E, where B is the set of vertices and E is the set of edges. So if you look at this graph, in this graph, we have the 5 vertices, like 0, 1, 2, 3, 4 are called vertices. As I told you, that is also represent node. and we have that line between that various vertices that is called edges. So we interlink these vertices or nodes through the edges. So in this graph, the set of edges, the set of vertices V that is equal to 0, 1, 2, 3, and 4, and set of edges are E equal to the combinations between that 0 to 1, 1 to 2, 2 to 3, 3 to 4, 0 to 4, 1 to 4, and 1 to 3. These are the various combinations of edges available in this graph. So this is one of the pictorial representation of graph in data structure. Next, let me move on. Topological sorting. The topological sorting is mainly used for scheduling the various kinds of jobs. So assume that we have multiple jobs in our company. So how to do these kind of, or how to schedule these jobs? Which job is going to be executed first? Which job is going to be executed next? So what is the sequence of scheduling the jobs? So this is one of the primary aim of topological sorting. Actually, we have to perform the various jobs based on the priority, right? So the job A may be complete first, then we go for job B, then we go for job C. So here, the jobs are represented by vertices. So in the graph representation, we can say the jobs are vertices. And there is an edges from the job X to Y. If the job X must be completed before the job Y can be started, right? So for example, if you want to construct the building, first of all, we have to complete the basement work. After the completion of the basement, we go for first floor. Then after completion of the first floor, then we go for construction of the second floor. So this is the process. So is it possible to construct that first floor without constructing the basement? But it's not possible. So this is very, very useful area. By using the topological sorting, we have to arrange, we have to organize the sequence of jobs which is going to be held in the particular organization. The topological sort gives an order in which we should perform the jobs. How to perform the jobs? What is the order of job? That is very, very essential information of the topological sort. So this is that a literal definition of topological sorting. It is a linear ordering of vertices, that is a sequence of vertices in a directed acyclic graph. So we know that what is the meaning of a directed graph? So that indicate that the graph which includes the direction of arrows, and acyclic graph. So we should know what is the meaning of cyclic and acyclic. The cyclic, which means we have the link once again towards the same point. If you start with the point A, once again that should be end with the point A. That is a cycle process. Whereas the acyclic means there is no cyclic process in the graph. So here, the topological sorting, the vertices should be in the directed acyclic graph such that if there is a path from vertices Vi to Vj, then Vj appears after the completion of Vi in a linear ordering. So first of all, we have to complete that Vi, then we go for Vj. So first point, then 2. This is the logic of the topological sorting. The topological sort is not possible if the graph has a cycle. As I told you already, if we have the cyclic process, it is not possible to perform the topological sorting because the same thing is repeatedly occur here. Then next we move on the procedure or algorithm for how to perform the topological sorting. In the step 1, find out the integrity for every vertices. If you have the graph we consist of that graph G that is equal to B comma E. That is a combination of set of vertices and edges. Here, all the vertices or nodes are represent the entities. So here, we have to first of all find out the integrity of every vertices. So we should know what is the meaning of in degree, what's the meaning of out degree. The term in degree, which refer to the number of edges coming towards the node is called in degree. How many number of edges coming towards the node X is called in degree. Similarly, how many number of nodes going out of the node is called out degree. In topological chart, we are using only the logic of in degree alone. So the first process is find out the number of in degree for all the vertices in the given graph. Then step 2, place the vertices whose in degree is 0 on the empty queue. So we have to use one queue, and after find out that in degree of each and every vertex, we have to keep the vertex which has the in degree value 0 into the queue. So we have to apply that NQ operations to insert the vertex which has an in degree 0 into the queue. After that, we go for the step 3. In the step 3, dequeue one vertex at a time from the queue and decrement the value of in degree of all of its adjacent vertices. So we have to remove one vertex from that queue and decrement the in degree of all of its adjacent vertices, not for the current vertices. The step 4, NQ a vertex to the queue if its in degree values falls to 0. After perform the decrement of in degree of its adjacent vertices, maybe some of the vertices in degree values goes to 0. So once again, as per the logic, we have to insert that vertex which in degree value 0 onto the queue. Repeat the same process from the step 3 and 4 until the queue becomes empty. The topological ordering is the order in which the vertices are dequeued. In what way? We have to dequeue the vertices is the topological ordering process.